Working on exponential function, there are two categories I've explained before. One where the base is greater than 1, the other place where the base is between 0 and 1. So you need to understand there is a set of points that you can use for every single question in one of these categories. If the base is greater than 1, you can always choose the values are as, okay, the common parent points. I can say the common parent points are going to be -1 and 1 over b, 0 and 1, 1 and b, 2 and b squared. And just make sure you follow these four sets of values right here. So if base is greater than 1, whatever the base may be, could be 2, could be 3, could be 10, so you can just make these calculations to make the set of parent points: -1, 1 over b, 0, 1, 1b, 2 and b squared. At the same, and you will get an exponential function that is increasing. Just an example. Okay, if the base is between 0 and 1, for example, it's a fraction 1/2, 1/4, 3/4, anything like that, then you will be able to make the set of parent points as, okay, -1b and 0, 1. Next one, you can just assume it is going to be just the opposite of that one. It's going to be 1 over b. That's going to be 1 over b squared. And that's it. And you know this is going to be a decreasing function. Hope this helps. Let's look at a few other examples. We have one here: f of x is equal to -2 to the power of x. You can make a table like this, and it is 2 to the power of x with all signs negative. 2 to the power of x, then put negative signs in front of it. We did this before. It is going to be 1/2, 1, 2, 4. Since it is negative, all these will be negative. So this is the basic parent points right here. And you can just graph those, and it is going to be -1 and -1/2 somewhere here. 0, -1, 1, -2, and 2, -4. And that is going to be our function right here. And definitely this is a decreasing function. And let's look at the attributes quickly, and we know the domain is definitely Example 3. 3 times 2 to the power of x minus 3. Let's quickly look at the basic parent points, and we know x is replaced by -1, so you can just say 3 times 2 to the power of -1 is like 1/2, then minus 3. 3 times 1/2 is 1.5, minus 3 is -1.5. 0 replaced here, so 2 to the power of 0 is 1. 3 times 1 is 3, minus 3 is going to be 0. X is replaced by 1, so that is 2 to the power of 1 is 2. 2 times 3 is 6. 6 minus 3 is 3. 2 to the power of 2, which is 4. 4 times 3, 12. 12 minus 3, 9. So these are the points that we have right here. -1 and 1.5. -1.5 is somewhere here. 0, 0. 1, 3. 1, 2, 3. And 2, 9. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, somewhere here, close to that point right there. And you also need to understand, since it is minus 3, that is a clear indication that the asymptote is at y is equal to -3. So let's make that 1, 2, 3, -3. So that is going to be our asymptote for this function right here. And you can see the function is graphed like this. That's going to be our function. Attributes, domain, same, -infinity to +infinity. Range is starting at -3, so it's going to be -3 to +infinity. X-intercept is 0, 0. Same thing for x and y, because it is passing through the origin. Asymptote is y is equal to -3. Definitely this is a talk about this example, -1 over e to the power of x minus 2 plus 1. Let's throw the values in here. I have just made the table, complete the table. When x is equal to -1, you can see that -1 minus 2 is -3. Since it is a reciprocal of e, then the -3 makes it a, just to flip the fraction, which is -eq plus 1. From the calculator, the value is approximately -19.1. Okay, when x is replaced by 0, 0 minus 2, -2, that becomes a e squared, -e squared plus 1. Value is -6.4. And that's actually approximate value. It's not actual value. And when x is equal to 1, 1 minus 2, -1, that would be -e plus 1, -1.7. And 2 is 0, 2 minus 2 is 0. Anything to the power of 0 is 1, -1 plus 1 is 0. And let's plot these values right here. So -1 is actually -19.1. So I mean, we can just have this here, 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe somewhere down here, just approximate value. And going to be 0, -6.4, 0, 1, 2, 3, 4, 5, 6, 6.4 should be somewhere here. 1, 2, 3, 4, 5, 6, 6.4. 1 is -1.7, -1.7, close to this point right here. And 2, 0, 2, 0. Also, you need to understand, since that is the case right here, +1, that is going to be our asymptote. Just make sure you make that asymptote. And the function is graphed like this. So this is our function. It is definitely an increasing function. Okay, the domain is -infinity to +infinity, and range is definitely less than 1, so it is going to be -infinity to 1. X-intercept is, that's right there, that is 2, 0. Y-intercept is 0, -6.4. And asymptote is y is equal to 1. The function is an increasing function. couple of other things you need to do. This is actually, you don't really need to graph this function right here to complete this. This is just looking at it, and by looking at this function, since this is a negative, the function is going to be a decreasing function. And also you need to understand the domain is going to be all real numbers, no doubt about it. It's always the same thing. And the range is going to be, it is starting from negative infinity, because you know this is the cap, this stops right there, so it's going to be all the way up to negative 8. Okay, that's the case. And down here, that is definitely an increasing function, and the domain is the same, negative infinity to positive infinity, and the range is starting at 11 all the way up to positive infinity, because that is plus 11 and this is positive. That is negative, that is why it is starting from negative infinity to negative 8, and this is starting from infinity 11 to positive infinity.